Hello. I hope everyone's doing well. I am gonna go over. I'm here in my guest bedroom. You can see it. There's a window. Woo! Um, I'm gonna go over how to do all the problems on this old test on line integrals that I gave. Since we can't do like a review where you can actually ask me questions in class, figured I would just walk through this thing. I have the answer key down below here, and I am going to tell you what I did for all these problems. So um, we're doing line integrals in 2D. So there's different kinds of ways that we can calculate line integrals. Um, we can do parameterization right there. If something is conservative, I can use path independence. And then Green's theorem also works as well. I think that's what I asked you to do or that's the way to do it in number two. So let's start with number one. The first thing I want to do is show that the force is conservative, this vector field, F. Um, if you look down here, I take the x plus y. This thing's annoying me a little bit. I take the x plus y there, and that is my m. Same notation and conventions we've used all along. The n is this x. So I want to show that it's conservative. To do that, I calculate the curl, or I want to show that nx and my are the same thing. So the curl does it for me. I calculate the curl. I partial this guy with respect to x, that gives me 1. And I partial this guy with respect to y, that also gives me 1. Therefore, it's conservative. So that's a pretty easy one to do. Next thing I want to do is use a direct parameterization so that the work done by that force as the particle travels from 0, 0 to 1, 1 along the path y equals x squared. So you could do a parameterization with x's or with t's. I did it with t's in this case. I'll come down here. I've got y equals x squared. I want to go, I use x equals t. I could just use x in this case. We've done a lot of it that way, and I think many of you would probably do it that way. But I'm going to take x equals t, and I'm going to take t from 0 to 1. If x is t, then y is t squared. I calculate my dx. It's differential of this line. Dx and dt are going to be the same thing. I calculate my dy. That is 2t. That's the power rule on this, but then times a dt. And then I do the integral. I take all those guys, and I'm going to do the integral of m dx plus n dy. So to do that, my m is the x plus y. So I take x, which is t, and y, which is t squared. So it's t plus t squared replaces the m. And then the dx gets replaced with a dt. So integral from 0 to 1 of t plus t squared dt. And then I need to do the n dy part. Well, n is x. And then what I got, x is t. And then dy is 2t dt. So I get t times 2t dt. And all that is going to get integrated from 0 to 1. So from there, I just combine some like terms. I have 3t squareds and a t. Integrate from 0 to 1. I get power rule, and I get 3 halves. Hopefully you're okay with that. Next thing I want to do is use path independence. So remember, if a force is conservative, which I've shown that this is, then the line integral that we do is path independent. What does it mean for a line integral to be path independent? Well, I can go from 0, 0 to 1, 1 along any path. The one that we calculated in part B was along y equals x squared. So if I'm using path independence to find the same work, then what I can do, I think the easiest way is just to use y and y equals x to go along the line y equals x, which I could draw it right here, but to go along the line y equals x from x equals 0, from 0, 0 to 1, 1. So in this case, y is equal to x, and I do parameterize it with a t here. You could totally use an x. And I get dy and dx and dt. They're all the same thing. So I'm going to go integral from 0 to 1 of m dx plus n dy, same thing. M is x plus y. So I'm parameterizing with t's in this case, so I get t plus t. Dx is going to be a dt because they're all the same. And then my t is, where's that come from? Oh, my n is x, so I get a t, and then the dy is a dt. Then again, we combine like terms. I get 3 t's in there, dt. Power rule, 3/2 t squared, and I go from 0 to 1 gives me 3/2. Let's see what part B or part D says. Oh, so this, here I know that the force is the gradient vector for some function because it's conservative. Once we know that the curl is 0, we know that that could have come from some function. So I'm using second FTC for line integrals in this case. So FTC for line integrals, fundamental theorem of calculus, not second. So what I need to do is, here, so I take that back, I'm incorrect. I'm just asking you to find the function that would have come from. So the easiest way to do this, and actually I think I said one of 2 ways here. I think for this year's class, I only showed it in one way. So I'm going to integrate this with respect to x. So the idea here is that like this is f sub x and this is f sub y, and they came from the same thing. So how would I get to f from f sub x? I would integrate it. So I integrated this sub x, that gives me this. But then I've got a constant with respect to x. What that means is that I could have a function of y. For example, I could have plus y squared, because if I took 1/2 x squared plus xy plus y squared and did a partial x on it, I would still get this out. So I say h of y. Then what I do is I derive this guy right here with respect to y. This term goes away, this term turns to an x, and this turns to h prime. So this derived with respect to y gives me x plus h prime of y. And in this case, I cross-check it, right? So I look at this, and I see how it relates to this guy. Well, in this case, it's not that bad because it's just x, and I got an x, and then h prime of y. So h prime of y in this case is 0. What I can do then is, f is this mess plus h of y. So h prime of y is 0. I should probably have a plus c here, right? If h prime of y is 0, then h, because I could integrate that with respect to y, is a plus c. So f equals 1/2 x squared plus xy, and you can have the plus c if you want. What I said a moment ago about second FTC for line integrals is I could ask you to find the same thing. You could get what did we get, 3/2? I could ask you to find that same 3/2 in part D by using FTC for line integrals. What I would do is evaluate this at 1, 1, and evaluate this at 0, 0, and subtract them. You should see that this evaluated at 0, 0 is going to give me 0. If I evaluate this at 1, 1, I get 1/2 times 1 plus 1 is 3/2. So that 3/2 is the same 3/2 that we found here. Okay, cool. That was number 1. I will make another video for number 2, and I'll do the same thing for 3. So hopefully this helps you as you're reviewing and remembering, because honestly, with all that's going on, you probably haven't thought about this in almost 3 or 4 weeks. Anyway, bye. Hope everyone's doing okay. Bye.